Okay, take out your notes. Take out your notes. So we talked yesterday that I think we'd be ready to test probably next week, either Wednesday, Thursday, or Friday. And again, our goal is to try to, how do you want to say it? We want to get far enough ahead to where we have time to review for the final exam, right? Because that'll be good. You guys don't want to just, if we took 3 weeks, so after this, so we have 2.6 through 2.9. That's a test we're going to take soon, okay? And then after that, we have Chapter 3 and Chapter 4. Chapter 3 is polynomials, where we use the rational roots theorem and stuff like that. And then Chapter 4 is going to be logarithms. And so the idea is, if we spend 3 weeks here, 3 weeks here, and 3 weeks here, that's 9 weeks. That's the entire quarter, right? So we got to average under 3 weeks if we want to A, have any time to take the final, and B, have time to study for it. So we don't have to take the final. What? On the math department they are. So. All right, so on your notes, this is where we're going to pick up. I don't have the graphs because I don't have this sheet. So what we're going to have to do is right in the middle, you're going to write this. Okay, we're going to start by making a table. We want to pick up where we left off yesterday. Yesterday, I taught you guys how to add, subtract, multiply, and divide functions and represent their domains accurately. So what I'm going to do is I'm going to draw a graph of each of these. And I'm going to do it by just plugging in some points. Now, we know what the graph of x squared looks like, but I'm going to come up with the exact points. We're going to plot them. So if you plug in -2, -1, 0, 1, and 2 for f, what are your outputs? What is f of -2? -1, 0, 1, 2. Do you have -2? Oh, I didn't ask. Take a step backwards. Simon didn't say. Simon says. What a great way to start the year with Link Crew. Simon says. Simon says, jump up. Now come down. Oh, Simon didn't say come down. All right. So now you can sketch this graph off to the side. I'm going to draw f of x in black. I'm going to draw g of x in red. All I'm going to do is plot these points. -2, +4. -1, +1. 0, 0, 1, 1, 2, 4. Is everybody okay with where I got this graph? My next graph, I plot points. There you have it. So I've got my two graphs. The only thing that we did there that pertains to your learning for the day is that we just kind of did some scratch work, so now I can do this. The directions in your notes say the following. The directions say sketch f plus g and g minus f, correct? So, as opposed to doing this, watch, I'll do it super quick. F plus g is going to be x squared plus x minus 1. Everybody agree? Well, that's a parabola, and we all learned how to graph parabolas on these type of worksheets. But as opposed to actually using what we know about parabolas to graph it, I'm going to use what we know about these two functions to sketch the addition of these two functions. So here's what I do. I locate an x value such as -2. So I want to see what is f plus g for the value of -2. And I look over here and I find the outputs. What is the output for f at -2? Or what's the output for g at -2? And if you take 4 plus -3, you get 1. So when you plug in -2 to f plus g, you get 1. We'll try again. Look, the table's right here, everybody. For an x value of -2, if you want to compute f plus g, you add the outputs. Now we made a table so you can see it. What is 4 plus -3? 1. So f plus g, okay, if you plug in -2, you're going to get a positive 1. All I did was add the outputs. Add the outputs. Okay, we'll try one more time. Make another column. If we plugged in -2 for f, you got 4. If you plugged in -2 for g, you got -3. If I plug in a -2 for f plus g, I get 1. Because I simply add the outputs. So let's do another one. See if, so what were you going to say, Grace? Oh yeah, exactly. So the next one's -1. If you plug in a -1, what is the f value for -1? 1. What is the g value? 1 plus -2 is -1. So we have a coordinate of -1, -1. I go to an x value of 0. What is f of 0? What is g of 0? 0 plus -1. So 0, -1 is another point. I go to the value 1. What is f of 1? What is g of 1? Add them and you get, so 1, 1. I go to 2. What is f of 2? What is g of 2? Add them. So 2, 5. And you see if we would have added those up all the way across, that's what we would have gotten. And that's the shape, which is x squared plus x minus 1. The next example, I want to subtract the values. Now, the next one, I want to subtract the values. I could make just another column over here and subtract the values, or I could look at the graphical representation. I'm going to do g minus f. We start at -2. What is g of -2? -3 minus 4 is -7. So -2, -7. I'm not doing 4 minus -3. I'm doing g minus f. So I'm doing 3 or -3 minus 4. Now I take the point -1. What is g of -1? -2 minus 1 is -3. So -1, -3. Now I do 0. G of 0 is -0. So 0, -1. Now I do 1. G of 1 minus 1, -1. Now I do 2. G of 2, F of 1, or F of 2, 1 minus 4. So 2, -3 is my point. Whoop. There you go. So that is the graph of g minus x, which is x minus 1 minus x squared. Question, Grace? Yes, very good. Yep. Not across the y-axis, but rather their axis of symmetry. If you notice, you have these 2 points right here that they are reflected over each other, aren't they? So your axis of symmetry for this one is actually -1/2. So you'd reflect it over -1/2. And your axis of symmetry for the black graph is going to be +1/2. That's the reflection. So yes, you can put the points over in there a second. Good observation. So on your assignment, you'll just have 2 problems to where you just look at the graphs, and you could go ahead and make a table and add the outputs together. And so add the outputs or subtract the outputs and sketch your new graph accordingly. Okay. All right. Flip it over. Compositions. So we're still in section 2.8, and section 2.8 is all about operations on functions. Today we will end section 2.8, but here's the deal. Yesterday I taught you how to add, subtract, multiply, and divide functions. Today we're going to learn about another operation called composition. And I just want to list for you so you understand and get a frame of reference. What is the first operation you learned how to do at a very young age? Addition. Then you learned how to subtract. Then you learned how to multiply. Then you learned how to divide. Life was great. And then it got really complicated. And my daughter came to me yesterday. She said, "Daddy, I know powers." Good for you. So I'll put a caret for a power. Very proud of her. She knows powers. So powers is an operation. Can you name another operation we have in mathematics that we may not talk about very often? Sure. Square root. Now, the fact is square root is just another way of doing a power. It's doing it to the 1/2. How about absolute value? That's an operation. How about this? Sine of something. That's an operation. You come out with a crazy number a lot of times. How about this? Log base 8 of a number. You did that last year, didn't you? How about natural log of something? You came out with answers. And in calculus, all of our time is spent on 2 operations. We do f prime. You don't have to write these down. But when people see that little mark on a function right there, what that means is we actually do limit as h goes to 0 of f of x plus h minus f of x all over h, which looks a little bit familiar to you from your last test, doesn't it? And so we do that anytime we see that little mark. The other thing that we do in calculus is another operation we talk about is this. And what this means is we take a function and we divide it up into rectangles, and we add an infinite number of rectangles together, which it's really cool. You'd love it. You'd love it. When you go to college next year, come back and take calc with me, because I'd love to see all your faces when you first get to add up an infinite number of rectangles. You'll say, "It's beautiful." an infinite area? In fact, no. I will show you. Okay, so the operation you learned today is composition. And this is composition. F composed of g of x. F composed of g. That's what that reads. And we define it to look like this. F of g of x. So, what you first need to realize is that these two things are the same. F composed of g can be written as f of g of x. And you'll see it both ways, and we just need to keep that in mind. What does that mean? How do we evaluate it? Well, here's what we do. We start with x. What do you think we plug x into when we're doing f composed of g of x? What do you think we plug x into? We plug it into g. And when you plug something into g, you come out with g of x. Once you get g of x, what do you think you plug that into? F. And when it comes out as f of g of x. So instead of plugging something into one function, we plug it into two functions. This is really important because in calculus, when we want to do this thing that you see right here, and we want to do that thing that you see right there, a lot of times we're looking at composition functions. And when we're looking at those, it kind of makes things tricky. So let's practice some of the basics. It says, given f of x is 2x minus 3, and g of x is x squared plus 2x, find the following. Find f of g of 0. I start with 0, and what do I plug it into? G. G of 0 is 0. So really, what you're doing here is you're evaluating f of 0. Because when you plug 0 in for g, you got 0. Yep, so now you take that 0 and plug it in for f, and you get an output of -3. So you just plug in twice. Yes. Well, f of g of 0 is the same thing as f of 0 because when you plugged in 0 for g, you got 0. Let's do another example that doesn't have so many zeros, okay? Let's do this one, g of f of 0. I start by plugging 0 into f. And when you plug 0 into f, you get -3. So now what you're doing is you're evaluating g of -3. Because when you evaluate f of 0, that became -3. So now you're doing g of -3. And so I plug in -3 for x. -3 squared is 9er. 2 times -3 is -6. 9 and -6 is 3. What's different about that one? It's got a little circle thingy. It's the same as what you see up there. So this is the same thing as f of g of -2. It's just written differently. You should know that it can be written either way and you still do the same type of operation. Okay? So I start by plugging -2 in for g. And g of -2 is 0. So now you're identifying f of 0. What is f of 0? -3. -3 is your answer. Now we want to do g of f of -2. What do I plug the -2 into? Plug into f. And 2 times -2 is -4 minus 3. So this is the same as g of -7. Now I take -7, plug it in for g. Okay. -7 squared is 49. Very good. 49 plus negative 14 is 35. This circle thing means the same as that. So if you see this circle thing, it means that you are putting G inside of F. The circle means you're putting G inside of F. I don't know. I did write a 10-page paper about the history of the sine function a couple years ago, but I've not written a paper on the history of the composition operation. I'll work on that. I'll tell you what, there's this amazing thing, it's called the internet, and you could probably look it up and find it too. And then you could report to class. Raise your hand if you like Alexa to do a class report on composition. Oh, all right. Sign up tomorrow. You can bring treats too. All right. Celebrate Alexa Day. Okay. Try ENF on your own. You try ENF on your own, okay? You can do it. Because you're brilliant. This f of 1. So we start by plugging 1 into f. If we plug 1 into f, we get 2 times 1 is 2, minus 3 is negative 1. So this is good. So f of 1 became negative 1. Plug in negative 1. 2 times negative 1 is negative 2. Minus 3 is negative 5. Arithmetic mistake. Some people plug it into the wrong one. They get used to going back and forth between F and G. And G of 1. We start by plugging. So now we're just going to work with G. 1 squared is 1. 2 times 1 is 2. We get 3. Now we take 3 and plug it in. 3 squared is 9. 2 times 3 is 6. 9 plus 6. 15. Better? Okay, what's different about G and H? We're not going to do I and J, but what's different about G and H? They just have X's. And so what they want to do is they want you to write a rule for the function. A rule. So what we're going to do is we're going to take this f of g of x and we are going to replace g of x. What is g of x? What do you plug in? X squared plus 2x. So g of x is that. So now I take that and plug it in for, I go up to my f function, okay? I'm going to take this x squared plus 2x piece, and I'm going to plug it in for the x right there. And so what you get is this. You get a 2 times something minus 3. And what is the something I plug in there? X squared plus 2x. That's what goes in. Now, can we simplify that a little bit? Sure can. Distribute, we get 2x squared, 4x, minus 3. Oh, no. Nope. Factoring is something we just do, never in a simplification process. Factoring is something we do because we want to, I should say that. Sometimes you'd factor simplify. Oh, I don't know. Did I start recording again? Yes, yes. Thank you. Okay. G of f of x. So this is going to be G of, what do you plug in? You plug in 2x minus 3. Well, I know that G looks like this. I got something squared plus 2 times something. That's what G of x looks like. So what do I plug in for that part? 2x minus 3. Can you simplify that? square 2x minus 3, we get 4x squared. So when we square this out, we're going to take 2x minus 3 times 2x minus 3. We gotta FOIL it out. So 2x times negative 3 is negative 6x. Negative 3 times 2 is negative 6x. So we get a negative 12x in the middle. Plus 9. Now we distribute our 2. Do any terms combine? What do you think of that? So if I give you a problem on the test, if I give you f of g of 0, and I give you two functions, yay, nay? Okay. And what if you had to do a problem like g? Plug in the function. Now, true or false, in Honors Algebra 2, this is something you did, very similar. You started to plug in actual functions into functions. You don't realize it, but she had you doing compositions last year. Because she's mean. No. She's not mean. She's very nice. Alright, flip it over. Here you go. So, you don't have this, okay? This isn't going to take us very long, but you don't have this on your sheet. I can't insert this on your graph very well. Maybe the drawing tools have changed on my computer since I started this. But I want you to try to do your best to sketch this graph on your paper. Give you some time here. And then on the side here, I'm going to write down all the things that we want to evaluate. And this, well, I'll step aside so you can write it down real quick. Serious, Mom? You say I laugh at my jokes? It's because I'm a funny guy. She just wants to be connected with class. It's all right. Very good. Now I'm embarrassed. Okay. So now we want to do f plus g of 2. So, if this is, the graph in red is f, the graph in blue is g, how do you think I do f plus g of 2? I go to 2 and I look at the outputs. What's the output of f? Negative 2. What's the output of g? Positive 2. And what is negative 2 plus positive 2? 0. So on the test, you should be able to look at a graph and appropriately do function addition, subtraction, multiplication, and we will obviously do, excuse me, composition as well. And add it to the g value. Yep. No, it's the this is the x, and then the output is the y. So watch this one. See if this makes sense. G minus f of 0. So I go to 0, okay, and I look at the y value, the output of g. What's the output of g right here? 2. Yep. So I have 2. Minus, what's the output of f? 0. So you have 2 minus 0, which is? Mr. Jeffrey was out there staring me down. All right. F times g of negative 1. So I go to negative 1. And what is f of negative 1? 1. What is g of negative 1? 1. And if you multiply those together, 1. F over g of 0. I locate 0. What is f of 0? 0. What is g of 0? 2. And 0 over 2 is 0. If 0 is on the top, it's 0. If 0 is on the bottom, undefined. What if it's 0 over 0? And it's super duper undefined. In calculus, you'll get 0 over 0 a lot. Yeah. It's indeterminate. It could be infinity, it could be 2, it could be 0, it could be -5. We don't know. All right. F divided by G of -1. F divided by G of -1. I'm sorry, not divided. Composed. Composed. Yeah, composed. So, what do I plug the -1 into? G. So I take that -1 and I plug it into G. What do you get? 1. So I could rewrite this as f of 1 because G of -1 is 1. So again, compositions are always 2 steps. So now I evaluate f of 1. So I go to 1. What is f of 1? 3. Oh yeah, yes. F is in red, so -1. So for the last one, I plug -2. Do I plug it in F first or G first? F. And F of -2 is +2. Now you plug in 2 for G and you get 2. What if you get that on the test? Sini, what do you think? Rank it on a scale of difficulty, 1 to 10. Ready, go. 1. Oh, wow. Ooh, Sini, Miss Confident. Keep that in mind while I grade your test. All right. Last section, nice and easy, okay? Okay, letter A. F of x is 2 over x and g of x is 3 minus x. Find f of g. So I want to write a composition. That means I take g of x, which is 3 minus x, and what do I do with it? Plug it into x right here. And if you do that, what does your new function look like? Does everybody see that? State the domain. Very good. X not equal to 3. Now let me show you why this is so interesting, everybody. Remember when we did domains yesterday and it was the overlap? Well, look at your first function here. If you look at f, what can x, what is the domain? What can x not be? X can't be 0. Okay, if you look at this one. How about 3 minus x? Are there any restrictions on the domain for 3 minus x? No, so the domain here is all real numbers. The domain here is 0. But yet when we do the domain for the composition, we get not equal to 3. So the difference is yesterday you could look at the beginning functions and identify the domain. Now you can't do that. You have to look at your final result and identify the domain. Okay? Got to look at the final result and identify the domain. So let's do this one. Now we want to do g of f. If I do g of f, I take f, which is 2x minus 6, and I plug that in for x right there. And if I do that, I get g of f is equal to the square root of what? (2x minus 6 minus 2), which is minus 8. Very good. For the domain, anytime you have a square root, you have to greater or equal to 0. Your domain is x greater or equal to 4. Now again, why is that interesting? Look at your beginning functions. F of x, the domain was all real numbers. G of x, the domain was x greater than or equal to 2. Neither one of those pop up in the domain here. Neither one. However, that's still the correct domain. So we've got to look at the end result. You guys are so smart. You're so smart, you probably don't even need to practice your assignment all the day, do you? I mean, all our learning is solidified. Should we just skip it all together? I looked at Taylor. Taylor said no, she wants the extra practice. I agree. I think we should probably have the extra practice. So I know this won't take you very long because, again, you're super smart. So hello to any friends out there who are gone from first hour or fourth hour. I don't know if we have any Bostonians, anybody who's gone there. If you do go to Boston, tell the Red Sox that they should give their trophies back because they do steroids. Also tell them that the Celtics have a horrible team this year and the Timberwolves will beat them every time they play them. So, well, Boston's are always looking for a fight. I mean, you've seen like Jersey Shore and stuff like that. Boston, New Jersey, New York, Philadelphia. Yeah. No, he got traded to Brooklyn. So they took Al Pierce and Kevin Garnett, and they traded him to Brooklyn. So Boston literally has just about nobody this year. So, all right, bye-bye. Oh.